Good morning, good afternoon. Welcome to lectures 53 and 54 on thermodynamics of materials. Yesterday we were discussing that the relationship between free energy and fugacity. So yesterday, last day we found what we found. We found that what we found huh, bigger. The fugacity found at equilibrium. Just add this at equilibrium, the fugacity of a solid or a liquid equals the fugacity of its accompanying vapor. Vapor, which in turn this is too lengthy. So let us not. Okay, vapor. That's it. Leave it there. Now, the fugacity of vapor, fugacity of the vapor is equals to the pressure of the fugacity is pressure, or low pressures is the pressure of the vapor. Pressure of the vapor, that is the vapor pressure. That is the vapor pressure. Vapor pressure. Is pressure. Pressure. Acha. Now the pressure of vapor is approximately the pressure of the vapor. That is the vapor pressure. When the vapor pressures are small. Which are often come across. Is small means 1 atmosphere is small. Which are often come across in our study. So the fugacity of a solid is its vapor pressure. Is it solid or liquid? Or a liquid? Is its vapor pressure? Also pressure, which is also called saturated vapor pressure. Saturated at equilibrium, underline at equilibrium here, which is also called the saturated or equilibrium vapor pressure. This we found last class. We proved this. Okay. Acha. Next take up Next, take up the effect of the effect of composition. Next, take up the effect of composition on the vapor pressure, fugacity, and gives free energy of a liquid or solid. Recall liquids and solids are called condensed phases. So let us take up this. We consider this situation, consider the following change, or the following process. What we have done? We have considered a pure liquid. Say I am considering liquid, or this can be I liquid, and there is vapor also. Okay. And there is a very good. No, liquid. That's what it is. Pressure is Pi0 I vapor in equilibrium. What is the pressure here? Pi0 is the pressure at a given temperature. This is called saturated vapor pressure or equilibrium vapor pressure. When I is pure, I liquid pure. Okay, I liquid pure, right? Pure liquid, and there is accompanying vapor. Okay, so liquid vapor equilibrium. Okay, now this state 1. Okay, this goes to state 2 what? State 2 what? I add another one to make it impure. X is a solute added to the system. X is a solute. Which, when added to pure I, produces a solution. IX. That is impure, hence impure I. Impure I by adding some solute. Say water, sugar. We add some sugar into the water, so water becomes impure, and then this will also exert a vapor pressure. Again vapor, there is also I vapor. But this is actually the pressure is now Pi. This is Pi0, Pi. So if you make a mechanical equilibrium, Pi. This is story, and again it is thermostated. Temperature, state 2. Unmixed state of I, or the species I. mixed state of the species I, of the species I. It's okay, it's okay, of the I. So, intention is what? Can I remove all these things? Let us find now. Let us find out gi bar minus gi0. What is this? Gi bar I, you understand? G is the free energy, you understand? So this is partial molar. Both are molar. One molar. Both are molar. Achha, by the way, it's okay. Very good. Very good. Partial. Let me write partial molar gives, actually I will write later maybe, just to save space, gives free energy, just write free energy only, molar free energy of I, means the species I. And what is this? Right? Molar free energy of I, not partial alone, molar free energy of I at its pure state. At the pure state. At the pure state, which is known as standard state. Pure, remember, pure state at 1 atmosphere pressure is the standard state for any species. Standard state, liquid and solid. Standard state. This is under discussion. Okay, this we will try to find out. So this is actually, so this is from this state 1 to state 2. So we start with this. Start dg I. dg is what? Achha, dg is what? VdP is what? Achha, let us not write that. Let us not write that. dg is RTlnK. Start from this better. This part actually we have. Or dgi, if you write dgi is RTlnK. Now, what we are considering here? Change in energy caused by change in composition. Note somewhere here, this is a well-known thing that when a solute is added to a solvent, the vapor pressure of the solvent, decreases. Solvent decreases. Note, when a solvent is added, that is here Pi. That means here you can note here. That is, you note here, Pi is less than Pi0. Vapor pressure. Water has a vapor pressure, some vapor pressure. When you add some impurity like say salt, sugar, vapor pressure of water will change. Just in passing, you may note vapor pressure changes with what and what. Which factors change vapor pressure of a liquid? Say for example, water. 3 factors. You may note this. That is, one is, first is temperature. Most important. As you increase the temperature, vapor pressure increases. This is one thing. Second is not so important. I may write down this about vapor pressure. Vapor pressure is a very important issue. Second is what? Then I'll take up. Second is what? Pressure, external pressure. But this increasing pressure increases the vapor pressure, but to a small extent. So, not very sensitive to pressure, external pressure, but very sensitive to temperature. 2 factors. Third factor is no change in temperature, but you just add a solute, then vapor pressure will be lowered. This is called lowering of vapor pressure, which is used in Raoult's law. The relative lowering of vapor pressure is equal to the mole fraction. That will study later formally. So this is reference lowering of vapor pressure, Raoult's law. reference, can I say this? Reference, this what I say, reference the lowering of vapor pressure. Lowering of vapor pressure, vapor pressure, vapor pressure, considered in Raoult's law. Considered in Raoult's law. In Raoult's law. Achha, since this is important issue, let me write this. The effect on what factor before in passing note this. In passing, main problem is here. So, main problem is this process. I'll take up this. This I'll find out. I've started here. Just in passing, which I will just give you just in passing. Note in passing. Note in passing that vapor pressure of a liquid is dependent on temperature, external pressure, on temperature A, B, C is the composition. Composition means purity, etc. When pure it is mole fraction, composition is mole fraction. Mole fraction. For example, just you can say, hey, hello, check this, check. It's okay. It's okay though. So I'm saying, for example, okay, as T increases, I tell you, as T increases, Vp, blood pressure increases. Very strong dependence, very strong influence. That's a very strong exponential influence. Very strong is influence. Exponential. As P increases, sorry, here actually I am getting the one. As T increases, you start this, start here, then I will remove this. Next here, start. As P increases, vapor pressure increases, but small effect. Very important issue. And third is as composition, as mole fraction, as Xi, mole fraction, okay, as concentration decreases as composition, as concentration decreases, as Xi decreases, vapor pressure, Xi decreases, Xi was 1 here, mole fraction decreases, okay, concentration decreases, mole fraction decreases, composition changes, vapor pressure decreases, Xi decreases, vapor pressure decreases, okay, vapor pressure of pi, okay, Xi decreases as composition, mole fraction, it's okay, understand, this you will easily follow. I have said this, okay, Pi. This figure is what? Retain this figure, retain this figure, Pi, retain this figure, it's okay though. Now can I remove this part? Note in passing. These three factors remember on vapor pressure. For example, I can give you effect of temperature. I can tell you 69 degrees centigrade. So consider water, the liquid is the system. Discuss. So water at 69 degrees centigrade, which is 342 Kelvin. What is the vapor pressure of water? We have calculated in the class 0.3 atmosphere. Now, when it is 100 degrees centigrade, is 373 Kelvin, it is 1 atmosphere. That means how sensitive it is towards temperature. So, this is a demonstration. Second, if we increase the vapor pressure, suppose 1 atmosphere, vapor pressure in a 1 atmosphere system, vapor pressure, so say inert gas, argon gas, total air, maybe some vapor pressure. Here, some vapor pressure, say here air and vapor. Okay, or argon vapor. So there is a vapor pressure. Say 1 atmosphere argon. Now make it 100 atmosphere inside. Then vapor pressure, and it is Pi0. Say again you consider Pi0 is say 0.69, 0.3. So consider the same temperature. Now it is under 1 atmosphere system. How will you make some 1 atmosphere? It is 0.3. Fill with argon. Argon and that constitute 1 atmosphere total. Total 1 under this 0.3. Now make it 100 atmosphere. Should be what? If it is remain same, it is 100. Total will be 100 atmosphere means okay. It is 0.3 and that will be the balance will be argon, 99.7. What is happening at that pressure? Vapor pressure will slightly increase, not much, from 0.3 atmosphere to maybe 0.4 atmosphere. Small effect of 0.358 because of the high pressure, external pressure. This is the second point. Third point is what? Water, you change the composition. So you decrease her, suppose you dissolve some solid or liquid, another liquid, then this will be actually impure water, and again vapor pressure will no longer remain at that value of 0.3 atmosphere at 69 degrees centigrade. It will be decreased, lowered, lowering of vapor pressure. It is not increase of vapor pressure, decrease of vapor pressure. These are the two. Now with this strategy, this I can write or enter to write. Okay. Now what is the? I am taking an integration here. Do this from standard state. Plus state 1. When it is pure state, is standard state. Recall, pure state is standard state. I said once. Standard state, state 1 to state 1 to state 2. State 2, non-standard state. Right, I am writing this side. Standard state, state 1 to state 2. What is state 2? Is the right here, non-standard state. Non-standard state, or many names, or state under study, or state under study, or impure state, solution state. So many names. So this. Then what will you get this? Let me write. So what is the name of this? This is state 2 is the impure state. What is the name? This impure means partial. GI bar. 1 mole. This relation is for 1 mole. Remember this RTlnK. VDP is RTlnP for 1 only. Otherwise it would be nRT. Recall that. So 1 mole. So molar. These are referring to 1 mole. Okay. GI minus reference state is GI0. Lower limit is GI0. Is what? R is outside. Temperature is a constant stuff. RTln Fi by Fi0 I am writing. Fi by Fi0. Okay. State 2 is the fugacity is this. At state 2, at state 1. State 2, state 1. This is state 2 fugacity. Fugacity has changed. For state 2, this is state 1. Now tell me what you know about further on fugacity. This is for what? For which one? This is about I is what here? I is the liquid one. Okay, so GI bar minus GI0. So I is the liquid fugacity. Then fugacity is equals to what? Vapor pressure. I told you at the moment ago. Fugacity is vapor pressure or so accompanying vapor. So vapor is what? You write here Fi0. Write here just in case you are interested. Liquid, but it is actually, these are also liquids. These are liquids. Liquid state. So is what? Why I am writing this? Because now I shall write Fi by Fi0 vapor. Okay? Liquid fugacity is vapor fugacity. First step. Liquid fugacity is vapor fugacity. This is actually Fi0 is the fugacity. And is what? This is also what? Okay, friend. This is in definition, according to definition is RTlnK. ln AI, new name, RTln, where AI is the act. Can I remove this part? Where AI is the activity, where AI is the activity of I, of the species I, at the state under study. I have written somewhere, na? State under study. At the state under study, with relative to the standard state, to the chosen standard state. This is the full expression for activity. What is activity? It says activity, you have to activity of which one? Tell me. State under study means activity here. Relative to the pure I, which is the standard state also. Pure state is the standard state, reference state. Referred to chosen standard state, which is Gaussian standard state or say pure standard state, pure state standard state. So this is the activity. So activity is actually a ratio, okay, and has no units. Okay, so given this, where activity is this, so I develop on this. This is the definition. So definition of, so according to the definition, above definition of the activity, above definition of activity, you write nicely. AI, start AI, very important. Whole life activity, and gives finality, and is what? Activity of I. I is the cell, condensed space. Activity I is first. You write what? Tell me. Fi by Fi 0 liquid. Okay, condensed space. So liquid. When I write liquid means it can be solid also. Liquid or solid. Okay, liquid. Okay, is what? Or solid. Okay, condensed space. Is what? Next you will write what? Fi by Fi 0. Here's a vapor, accompanying vapors. Okay, and then what you write? This is exactly equal, because equal at equilibrium is equals to Pi over Pi 0, because this is a vapor pressure ratio. Why? Fugacity is pressure roughly when it is low pressures. That we have actually discussed fugacity. Fugacity of gas. This. See, after this it is a vapor phase, gas phase study, gas phase thermodynamics. Here now it has equilibrium study. So this step to jump. So this is activity Pi by Pi 0. Okay. So we sometimes write. We sometimes write. So that is. It's a note. At low pressures, which we consider often, which at low pressures, which we consider often. देखिए fugacity. Oh, did I hit this? No. Fugacity is, right, is Pi. This you know is Pi. This is a gas. Okay. But if you want to be, but for higher pressures, we write what? Since they are not equal, this is very interesting. Today I am giving you is gamma I Fi. Measures a deviation from that behavior. Fugacity is pressure for ideal gas, but non-ideal system then should be gamma I, sometimes written as gamma I. This is called fugacity coefficient. Fugacity coefficient. This you note this. This is something I tell you today. Fugacity and pressure equal, but not equal. You have seen most cases. Then how you relate them? I have written, so very sorry, very sorry. Fugacity is pressure, sir, ideal, non-ideal, gamma I. This is called fugacity coefficient. Sometimes use the phi I. Sometimes use sometimes different symbol use. Sometimes I don't have space. Don't worry. Leave it there. Leave it there. Fugacity coefficient. Okay, over. This part is okay. So you have understood this. Gi bar RTln is there. So please tell me, activity of I. Read this well. Read this well. Follow. Activity of I means you are chosen. I at which state? Address activity of I at the state under study. What is the state? Tell me. This one. State under study. State under study. What is the activity of I? If you ask me what is the activity of I here, I will answer soon. You can guess also. Activity of I at the state under study relative to the chosen standard state. What is that? Pure I. So this is the meaning. I am giving by an arrow. Activity. Actually, I'm writing here. Then does not disturb this. I'm writing this way. Okay. Where I right. This is over. This I can. This is over. So I'm writing once more. Follow. This you remember always very serious issue. Minus GI0 is RTln AI. Activity you have to consider this activity of the species I at this state relative to the, this is the whole thing always, and activity is a ratio. Activity of the species at this state. This is a state under study, impure state, state under study, impure state, solution state, non-standard state, so many names relative to the standard state. Okay, this I have written here in language, but I am giving by arrow. So this, okay, gi bar minus gi0 is RT. Or here if you write this, okay, very good. This is okay. Here also, say here, simply here. Okay, I am showing here similarly. AI is Fi by Fi0. I don't have to write liquid or vapor because their ratio is same. Achha. What is the activity of the state under study relative to the chosen state? It's fugacity and that's fugacity. Or vapor pressure. Okay, this is the whole issue. And another thing I wanted to tell you, another thing, please, if you even accept this, sir, deviation, accept, then you will see something interesting. Activity is Fi by Fi0, I am writing here. You may accept this quite satisfactorily. Why? Sir, gamma, let gamma there, and as ratio they cancel. Leaving behind Pi by Pi0, so it's not too bad to write that Fi by Fi0 is Pi by Pi0. Why I am writing so much Pi by Pi0? These are measurable quantity. Vapor pressure is a measurable quantity, and we understand this. So fugacity of solid to fugacity of vapor, quickly move on to that, and then you take up fugacity of gases. Vapor means gas. You already have started. Okay. So this part is okay. So this is we have answered the question. What is GI bar? This is very important relation. I am writing once more. Is over. Question is over. So write. Very important. Number one, maybe if you ask me, this is the number one relation in thermodynamics. Not actually, you cannot afford to miss this. Even actually, you may do without first law. I should not say too much. The number one relation, maybe I will give you another relation, number one, number two. So maybe interchangeably used, but this today I will give you. Over. So this is very important. Nothing. What else I will tell? Now formal definition of GI bar. Now take up. Move on first now. Formal definition of what is GI bar? I told you. Tell me. What's the name? Partial molar gives free energy of I. Okay. Formal definition of I. What is GI bar, by the way? Which is equals to, tell me? Which is equals to, tell me? Have I written anywhere? No, I have not written there. No, I have not written there. GI bar. I have said GI bar. This is GI bar. Yeah. G of this, I at this state is GI bar by minus GI0. It's okay. The rate of yes. rate of GI bar. Acha, I am giving you. Don't do this. Do work this way. Formal time. Start. G is a function of pressure, temperature in the system, Ni, Nj, Nk say. The more multi-component system solution. IJK. Iron, manganese, silicon. G, since extensively I have written, what should I write here in principle? G prime. Extensive, intensive, you are little bit careful, G prime. Write G, but if you treat that it is extensive, no problem. G prime is a function of pressure, temperature. You remember, for fixed, this is for which one? For which type of system? Tell me. Valid for variable mass with or without, but here I consider with variable, with or without variable, with variable composition. For systems with variable mass and variable composition. This solution system. Example e.g. solution system. e.g. one solution system, chemical reaction system. Start this, okay? It can be without also, but let us consider this. So dg prime is what? You know very well. What is quickly? Formally start del g prime by del p at constant temperature Ni, Nj, Nk. Quickly dp, as you know, as you have to develop this. Del g prime by dt at constant pressure Ni, Nj, Nk dt, plus continue del g prime del Ni at constant pressure, temperature. Tell me, Nj, and other than Ni, dni. Continue, plus del g prime dnj, pressure, temperature Ni, Nk. Happy? dnj plus del g prime del nk. Just since it is first time I am writing in so many terms, all terms I am writing, taking this trouble, but later on maybe I will give dot or one I will write. Tell me what I will write. Tell me pressure. This is called, this is total derivative. Okay. Okay. Total differential partial derivative. Total differential. Okay. Total derivative. Total derivative. No, this is total differential. So this is d whatever it is, okay. N I N J, and also you write here d n k. Now I tell you what at this stage. Can I write? Here? Can I perhaps I can remove this, no? I can raise valid for this is such a written that this is known as famous GI bar. This is study of this. What is definite GI bar? This is GI bar. Then what is this? J bar. What is that? GK bar. Now tell me, or dg prime under constant pressure and temperature. Under constant temperature pressure is what? Tell me under constant pressure temperature. These first two terms drop away because 0. So remaining this one. What remains? You write this. GI bar dni plus gj bar dnj plus gk bar dnk. That is the effects of this. So it box this. Important relation. One important relation. This is a GI bar. So I'll write this. Another one I'll explain this. But let me finish now. Now what is the definition? Definition of GI bar as you got it now. Definition of GI bar, which is nothing but del G prime, right? Nicely, del Ni at a given temperature, pressure, constant temperature and pressure, and other stuff, other accompanying species constant, number of moles of them, constant. This is the GI bar. Definition of GI bar is what? This is definition. The rate of change of, what is that? The rate of change of the total, what we say G prime is what? Rate of change of this. Rate of change of dsdt, rate of change of displacement is the velocity. Rate of change of G prime, of G prime of the G prime is what? Free energy, total free energy of the system, G prime, total free energy of the system, of the total free energy of the system. What is the name of this? G prime rate of change of the total free energy system with Ni moles of I when dn. Acha, wait a bit. Please, just of this, the change of free energy of the system for change of free energy system for 1 mole of Ni per rate of change in free energy system per 1 mole of Ni. Maybe I have to edit this. When dni mole is added, when dni moles of I, is added to the system, keeping is added to the system. So change of the system, what everything, the rate of change of the total free energy of the system with. It is better. The rate of, I'm maintaining this. The rate of, please don't mind, rate of change of the total free energy of the system with Ni. Rate of change with respect to Ni, with respect to Ni, it is better. With respect to Ni, when this when 1 mole, when dn, I'm sorry, with respect to means per mole. When dni mole is added to the system at tell me, the addition must be under certain condition at write nicely, as a system at constant temperature, constant pressure, and constant number of moles of the remaining species, namely JK, remaining species, namely species are JK. So what you have to do? You are adding Ni. So if you sketch this, if you want to sketch this, then you can easily sketch this. Remove this here. Just return this. The total free energy system with respect to Ni when dn. And more.
You can remove that off. You can remove that on inside.
dn mole of dni mole of I. I have that after dni mole of whose? Of I, or species I. dni of I is added to the system. Is like is system. You consider this. You have a IJK solution. Follow this. I box IJK solution. This is solution. It has GI bar. It has GI bar. It is GJ bar, GK bar. What are these? These are partial molar free energy of IJK. Why partial? Because this is solution. And what is so molar means for 1 mole GI bar, which is, remember, always GI bar is different from GI0. GI bar is different from GI0. It is impure GI bar. And what is this? You are adding DNA mole. DNA moles of this here. Add to this with no J, no K, no temperature change, means at the same temperature, right? Temperature is thermostated, and there is a pressure, constancy, temperature, pressure, constant. You are adding DNA mole of I, DNA mole of I, DNA mole of I is added to the system. Then what is the consequence? What is the change in free energy? This leads to change in free energy of the system. For this addition, it is what? There is a dg prime will be changed. Okay, dg prime is what? GI bar times DNI. Why? You try to follow. Why? That means, or GI bar is what? Per mole. Per mole, this rate actually per mole, but this you find out, or GI bar. DG prime is GI bar DNI. Okay, it's my point. So GI bar DNI. Okay. Note this. Okay, so I tell you what. Note that GI bar. Okay. So so wait. Achha, try to follow this. Now tell me, suppose there are, what is G prime? Fine, G prime. Suppose, achha, what is G prime? Tell me, what is the G prime of the system before addition? Before addition, what is the G prime of the system? Initially, G prime is what? Tell me, G prime means the whole system comprised of IJK. So how will you get this? GI bar is the contribution of 1 mole of I, but how many moles are there? Suppose Ni moles. Ni say, right here, GI bar, right? GI bar, and how many it is? Ni. GJ bar, how many it is? Nj. And GK bar, how many? Nk. This is there. Then what is the system before addition? G prime is Ni GI bar, Nj GJ bar, plus Nk. Very easy. This is very easy to follow. Again, I box this. This is very important. So, so is the definition is okay. The rate of change of the total energy of the system with respect to DNI. So dg prime by DNI, rate of change when DNI. Actually, why? Note. Oh yeah, right. It's okay though. It's okay. Next, note. You try to follow this. GI bar is your interested rate of change. So del G prime DNI. You are saying this. I'm not writing other things. So what if it is delta G prime delta Ni? Please follow this. This definition follows when DNI mole is added. It is not a ritual. You have serious. There is an issue there. DNI mole is added. Why? But this is wrong. This is wrong. Analogy. It's okay. It's okay. Analogy is what? Analogy. Recall analogy. Cp is what? Del Q, del T at constant pressure. Is it Q by delta T? Why not? Because what is the answer? I'm just removing this. You don't have to. You don't have to. What is the why? Why this is not true? Since Cp is a function of temperature. That's why you cannot. Still more analogy, high school analogy, still another analogy, still another analogy. Remember this. What is velocity? ds ds by dt, ds by, sorry, not partial, this is only solely function of this. Let me write nicely, ds by dt for a non-accelerating particle, for an accelerating particle, for an accelerating particle, sorry, we know this is not what, tell me, delta s by delta t. Why? Because velocity is a function of time, or this every moment velocity changing, accelerating particle. Since v is a function of, since is not, since right here, since as follow, since v is a function of time, hence s also, v is a function of time, so not allowed. DSD differential, Cp is a function of temperature, so not allowed. So not disallowed, disallowed. Here also Gi bar is a function of Ni. Why? Gi bar is a function of composition. Ni change, if you add the actually finite moles of I, composition will change. So I, certain moles, if we add actually 3 moles, 4 moles of I, and say divide by that, like in the form this, it is 3, and see what is the delta G. No, that will not reflect Gi bar. Gi bar you want to reflect where? Follow. Gi bar already here in the solution now, no addition, sir. Try to bring out the meaning of it. So system is Gi bar. What does it mean? How will you reveal this value of Gi bar? Now by this method, you have to add some moles of iron. You will add cautiously so that this does not affect the composition, because composition will affect the Gi bar. Since you are going to define Gi bar, so which Gi bar at this state? So do the addition such this composition is not affected. So how can it be done, sir? Added and no change in composition. We have solved this answer. Okay. Before, what is this? Add dni moles. dni moles corresponding change is dg, and get the ratio. There is a per unit mole, hence molar. This is the effect of molar addition. Don't don't. If you add delta, say 3 moles, you say I will see 3 moles you added, say 3 moles and corresponding change in energy. So divide by this, that will be wrong, because in the addition of 3 moles, what has happened? The composition has changed, but you wanted to get the Gi bar here at this. So this is actually what is this? Gi dg by. This is like actually what I tell you. What is this? Okay. Here also dq is Cp dt. ds is what? By the way, here also very easy for you. This is okay though. ds is what? Follow like this. Follow v dt. See, dt have used, time change. Get the displacement. Get the free energy change. Get the moles added. dni. V remains the same. Means normally V is a function of time, but since dt is considered and corresponding ds is considered, V is remains there. So it is referred back to that state. What is the velocity at a point at a given st? Now V dt. The next point you have to consider, but this way. So similarly, your addition must be such that this does not change the composition. So then you will not get this. So it is finite changes will not give this. So that why this? Addition must not change the composition. So shall I write here? Note why this nitrogen? So I am writing. Remember, why actually writing this? This actually I have already removed. I will write once more. So why dn moles? Why dni moles of I are to be added? Sorry, go slowly. Are to be added. Answer: the composition on addition composition must not change. On addition, the composition of the solution must not change. This is answer. Okay, because if it changes, then actually what you will say. Okay, so let us take this exercise. Since if you have difficulties, let us not. Hey, sorry, why? Sorry. Take care. Actually, sorry. I thought actually it will not rub up easily. Please manage this. Okay.
Yes.
Is okay to? Acha son, slowly. Let answer this question. Answer this question. Very practical question. Problem. Suppose Ni. Suppose answer this. Suppose Ni is 30, Nj 40, Nk 50 moles, and corresponding Gi bar is say 100 joule, Gj bar 130 joule. Just randomly I'm writing 140 joules. Say suppose. Now first tell me, this is the state. This is the beginning state. This is the beginning state before addition state. This is initial state. That is before addition of I. Initial state. So further clarification. The further clarification, right? Further clarification. This is important. Further clarification on. This is a very important issue on Gi bar. Follow. More time you spend. This is the initial state. That is before addition of any I. Before addition of any I. A sketch will be helpful also. I'm just drawing a nice sketch now. A simple sketch. The one I already drew. Once more. Sir, I J K solution. I mean 30 moles. Okay. 30 moles. What is 40 moles? 50 moles. Okay, I partial molar finality I'm not writing. Tell me any question you tell me, ask me, sir. This is the initial state. Initial state. Why Gi bar? Gi bar is 100. Is this Gi 0? This is Gi 0. Gi 0 is a pure I. Why you get? That's why Gi bar is relevant here. Gj bar is relevant here. Is okay? This is initial state. That is before addition of any I. Any I. No I is added yet. So this what is the question? Follow. If you solve this problem, then you will be. What is G prime? G prime is what? Tell me. What is the free energy of this system? Of this solution? What is G by? That, sir. Contribution of each, or what is the ask it is? What is your per mole contributions? 100. How many are you? 30. So that is the. So write this once more. Ni Gi bar. Write this plus Nj Gj bar. Never forget this. Very easy though. So what it comes out as? Please tell me. 30 times 100 plus 40 times 130 plus 50 times 140. What they will be? Let us do a calculation. 3000 plus 5200 plus 7000. It's okay? It gives you 10,000, 15,200 joule. This is the free energy of the solution IJK. What is the solution? Name of the solution? Solution I made up of IJK. Right? IJK solution. IJK. Solution right here. Solution IJK. Write nicely. Okay, write nicely. I J. Sorry, no hurry. This is so this is the free energy. One value. Now you added. Say I'll tell you. What I did, add the Ni. Okay. Now what is the next? Tell me what is the G prime. So G prime state 1. G prime solution, right? G prime state 1 before addition. So G prime, this is G prime 1. Please tell me now Dni mole added. Now on addition of Dni, not here, not good. These are all explained. Not here. Once you are clear, confident, then you can move on. Now on addition of, now next, on addition of Dni Dni moles of I. Now what? Now again I ask this question. What is G prime and I state 2? Okay, this call it state 2. call it state 2. I will not show this state 1, G prime 1, G prime 2. What you say, again, do the same way. What, right? Ni, Gi bar, quickly write Nj, Gj bar, Nk, Gk bar. Now tell me one by one. What is the Ni? What is the Ni current now? You have added DNI moles. You have added DNI moles to this, okay? Good boy, good boy. Pressure. I should not. This temperature. You actually, what I wrote here, you add now these DNI moles added after addition. Okay. So it is no longer 30, but 30 plus DNI. That's right. 30 plus DNI. You can get easily. What is the GI bar? What is the GI bar? Tell me. Very interesting. GI bar cannot change. GI bar is dependent on composition, sir. Given temperature, pressure, composition, sir. I will show that graph. GI bar is a function of composition. Remind me. Composition. So composition has changed with the addition of DNI to any given no. So it remains GI bar. What is that value? 100 joule. Follow this. I will show you what is the purpose of adding this definition. 100 joule plus Nj is as before. Nj is as before. 40 into 130. They have not changed. Plus 50 into 140. What is the addition? Result is obviously the previous value 15 2000 plus DNI 100. This is actually GI bar. Right? So this is actually GI bar. So what is this? What is the G prime 2 minus G prime 1 is known as DG, or DG is G prime 2 change in difference, small change, okay, delta G, see delta G, but it is for DN. So is what is the answer? Tell me, what is change? This is 1500, right? This 15,200 plus DNI 100 minus 15,200 gives you DNI 100 gives you DNI GI bar. Back. GI bar unchanged. GI bar. So what is GI bar then? What is GI bar? That means DG prime is DG. This is DG prime. Sorry, DG prime is, or GI bar is DG prime by DNI. As you know. This is answer. This is a demonstration of this. But see, why, sir? I will get the same result. I will show you. See where the shoe pinches. You not DNI. You write here added delta Ni. Suppose you add delta Ni instead. So delta Ni is what? 3 moles. Let us see, do it. Where you will start? You will say, I'm explaining. It is no longer DNI but delta Ni. What is that value still? 3. I am giving. Sir, no problem, sir. Should be same way. Where I will get stuck? You write this. If it is DNI, you got this result. Will it be 3 moles I have added? Can I write 100 joule anymore? 100 partial molar free energy value is a function of composition. 3 moles has changed the composition. Now, composition is such a thing. Composition means one change and the other change. But anyway, suppose it has changed the composition. What is GI bar minus GI joule is RTlnK. So it is no longer different. So you will not get, and you might say, if it were, what is the result you would get? Change would be what? In this case, 3 times 100. 3 times 100, okay? The delta is 3, okay? 3 times 100. Then in that case, what it would be? Tell me, what is this? DNI times delta 3 times 100, delta Ni times delta Ni. If it were true, then delta Ni GI bar, okay, little bit comes though. Then GI bar would be what? Delta G prime by DNI. Okay, GI bar is delta G, delta G. What is this? This will be delta G. This DG will be considered delta G, no more DNI, delta Ni. But this is wrong. Okay, see my point. So why main trouble is here. Okay, so addition should be done such that composition does not change. If you ask me another way to tell me, sir, I will add 1 mole, still 1 mole, finite. Then what you have to do so that your composition does not change? This I am not written, but I will write it. Then what you add finite moles, 1, 2, 3, say 1 for standard, 1 mole, still you may not have any change in composition. When it can be possible? Large quantity of the solution. So 10 to the power 6 moles of I, and you are adding only 1. So composition will, composition is what? What is composition? Now Ni by n total. Ni by what is xi here? What is the composition here? 30 by 30. Xi is what here? 30 by 30 plus 40 plus 50. By addition of dni, it is 30 plus dni is 30. No change in composition. But if you add here say 10, then it is significantly changed. But if you still add actually this is a 10 moles or 1 mole for that matter, then a large quantity of the solution, that is alternative definition of GI bar. Shall I remove this? Alternative of this. So if you must add 1 mole, finite moles, then this is the answer. Alternative definition of GI bar. So finish this. Quick, follow. GI bar is what? When 1 mole of I, not dni mole, 1 mole of I is added to a large quantity of the solution, large means infinitely large, of the solution I, j, k, the change in free energy at a given temperature and pressure, and other species, moles of jk fixed, moles of jk unchanged. Then tell me from this, tell me, suppose this is allowed now, then tell me what is this? 1 mole you have added, then what is this? 1 mole, then the G prime, then the change in the gives free energy of the system. Free energy of the system is the GI bar. Then this change, then when the change in the gives free energy of the system is the what? Tell me, is the what is GI bar? Right here in this side, right here. GI bar is delta G prime by delta Ni, where delta Ni is 1, but addition is here 1 mole will not change. Note here composition has not changed. Note here also composition or mole fraction or composition or xi has not changed due to addition, has not changed due to the addition because of 1 mole against large quantity. This you understand. 1 you added to the 10 to the 6, what it will happen? Nothing will happen. So no change at the end. So yes, so what is GI bar? Change in free energy of system when 1 mole, that, or rate of change, this okay. This is GI bar. Next I tell you, ask you what? GI bar is, I am telling you, GI bar is a function of composition. The function, what is composition, sir? Xi, mole fraction. What is the name of this symbol? Xi. Quickly follow. Actually follow this. GI bar basis. GI bar is GI 0 plus RTln AI. Will you accept AI is a function of composition? Note that why GI bar is a function of composition? Because AI. Note that GI bar is function of AI and AI is function of composition xi. So GI bar is function of composition. You may ask, sir, quickly write something. AI is function of composition. How? AI is a function. For example, e.g. AI is xi. Activity is xi. Possible. Except example, what is this solution called? This in which type of solution? They call Raoultian solution. Raoult's law. activity is mole fraction. 50%, 0.5 mole fraction, activity is 0.5. Or alternatively, gamma I xi, here again activity is, this is called ideal solution. Raoult's law, ideal solution. This is non-ideal solution. So you keep in track this. Gamma is known as activity coefficient. Please follow this. Okay, don't hurry. Follow this. What I am trying to show you, GI bar is a function of composition all the time saying, no? This whole basis is GI bar. You don't change the composition, then GI bar will be distorted. GI bar will be distorted if you add. But if you add this, then you can do this. But I tell you. Let us spend some time since already active question. Now tell me. So GI bar is GI0 is RTlnK. I am plotting. You follow this. Xi is moving from, do this. You are plotting GI bar. You want to see how GI bar is changing with Xi bar. I am giving Xi is 0 here, 1 here. This is pure I. Xi is 1. Okay? Solution. What is this value? This is GI. Tell me, what is the name of this? GI bar takes the value of, when it is pure, GI 0, standard. Just see. When AI is 1, GI is GI 0. Okay? Quickly. See how it changes, you know. GI 0 is certain value, finite value. GI 0, when this pure, then as Xi is decreasing, why Xi is decreasing? From 1, something is added perhaps. J is added, impurity. Then you see this free energy gradually decreases. Can you tell me what value it takes when there is no Xi? Achha, Xi or AI for that matter. For that matter, AI is a function of composition. AI is Xi itself sometimes, or this. So AI is also likewise 0 to 1. When AI is 0, what is the answer to GI bar? Tell me. When AI is 0, both are 0. AI is 0, ln 0 is minus infinity. So GI bar will take the value of minus infinity. So this is the positive side. Positive. This is the 0. This is the negative side. Negative side. Right? Negative. So what it will be like? Minus infinity. Minus infinity means, this is how GI bar changes with composition. Pure maximum value. I told you once, note. GI bar is always less than. GI bar, 1 mole free energy in pure state is less than 1 mole free energy of 1 mole of the pure substance. Impure substance has less free energy. This is clear. Okay, GI bar is GI 0. Okay, very good. GI bar, this has happened, pure becomes impure. What is this difference? RTln AI. Okay, AI is what? Less than 1. Okay, AI is for pure substance. Achha, when AI, when this is the state under study. When it is pure, then what is the AI? When it is GI 0 itself, then what is the AI? 0 means 1. Activity. So for pure sum, activity is 1. Okay. See what I am trying to say. GI bar minus GI 0 is what? RTln AI too. So AI is, for suppose it is impure, this pure, then AI must be less than 1. Activity of impure must, remember, for always, activity of at this state under study divided Fugacity and vapor pressure, activity of this species of this state referred to this state. This is activity. So this, okay. So activity is what? So GI bar minus GI 0 is what? RTln AI. AI is less than 1, so negative. So this change in free energy is negative. That is actually a criterion of spontaneity. So mixing is a spontaneous phenomenon. This I told you. Okay, thermodynamically it is seen that GI bar minus GI 0 is GI less than means activity must be less than 1. Okay, the moment you add something, then this is spontaneous. Mixing is a spontaneous. You cannot stop it. Okay, anytime it come in contact, it will mix up. Mixing cannot be stopped. Okay, maybe limited mixing, but all the same. So is okay though. This is the see. So what I wanted to tell you, GI bar minus GI 0, GI is GI 0. Okay. Very good. Achha, activities. Achha, now again list. Here list something. Okay. Now list. Okay. Achha, note. Please tell me. Note. Activity of I. Pure solid. What is this value? Tell me. Pure. I for example, I is iron. Iron is what you write. Again, write Fi by Fi0 fundamental is what vapor pressure wise Pi by Pi0. Since pure solid itself, this study understudy, but I consider pure is the understudy. So it is Pi0 by Pi0. So pure substance, so pure solids have unit activity. Okay, liquid, solid, pure solid or pure liquid. Please complete this. Now this is clear. When it is impure, tell me. I have already answered. Right here. Impure, solid, liquid. No, less than. But you write again once more. Right? Is sir is not one. Is less than one. Good. First is less than one. Means what it is, sir? Xi. If it is ideal mixing. Impure means mixing is there. So when it, I already said ideal solution, right? Ideal solution. Raoult's law. Ideal solution, Raoult's law. Right? Once more. I am actually summarizing here. Is what? If it is non-ideal, gamma xi non-ideal. Since I have already mentioned, this is about solid. Clear? Solid condensed phase. This is about condensed phase. Okay, right here for condensed phase. For refer to condensed phase. Condensed phases. Solid liquid. For gas, complete this since I am started. What is gas? Okay. Actually, what is mole fraction by the ideal solution? Mole fraction, again take up this. Mole fraction is what? Xi is what? Tell me. Ni by n total. So, what is n total in this context? Ni by Ni plus Nj plus bus. Okay, this part is over. So, condensed phase for condensed phases. It is not clear actually for condensed phase. Okay, these two is this okay. This I don't want to disturb for condensed. As for solid liquid is better for solid liquid. Then for gas, for gases activity, for gases what is activity? AI, tell me. For gas, hydrogen gas, oxygen gas, nitrogen gas. AI is what? Again, right same. This cannot be avoided. Acha, by the way, you note this. Okay, you have noted this. Acha, vapor pressure. Tell me one thing. So if you have followed this, tell me. This is vapor pressure. What is activity? Up, say, what have written there? Is one. Go up there where it is. So it is for pure. Okay, if it is not pure, then what is? Pi by Pi0. What temperature? Vapor pressure is a function of temperature. So reference state is a pure state. Has vapor pressure, impure state vapor pressure. But temperature, sir? What temperature? For this and for that, or same or different? Same. Temperature has not changed, sir. There is no comparison. Both have the same temperature. So that's why remember this comes actually in that figure. Temperature same. State. So sometimes it is written. I tell you. This is Fi by Fi0 at sometimes some people write this way. Means same temperature they are exposed to. Standard, non-standard, same temperature. Standard, non-standard, same temperature. See, all derivations are under constant temperature. Okay. What I am writing here. Ai is Fi by Fi0 is sometimes written as or maybe written as Fi by Fi0 same temperature because treated. All is also Pi by Pi0 same temperature. Remember this. This is not written. This is simple thing is simple. Okay. Vapor pressure. But obviously, because vapor pressure is a function of temperature, in one case one temperature, in another case another temperature, it cannot be. Only it is caused by what? It is caused by what? This whole thing caused by what? Mixing, pure to impure. Okay. So activity of this I in the impure state referred to the pure state. Okay. Good boy. For gas, complete this. Gas again start from this. So that's why suddenly I actually moved to this. This is so important. Fi. It will be actually. Sorry, I have actually lots of things to tell. Fi by Fi0. Sorry, Fi by Fi0. For gas, what you write? Difficulty. Fugacity. I again consider ideal behavior. Here actually see there's some ideal behavior is Pi. Now is a good question now for you. Follow. Gas, not gas. This is condensed phase. Follow this. This you distinguish, otherwise in trouble, deep trouble. Sir, gas I was studying. First one I cannot stop. Activity of is pi by pi. What is the pi zero? What is the pi zero? Gas, nitrogen. What is the pi zero? The standard state. P nitrogen standard. Do you have any idea? What is the standard state pressure? So go back to that enthalpy beginning, heat of formation, the standard heat of formation. What is the standard state? For solids, liquids and gases. Formally, standard state was pure state at 1 atmospheric pressure for solid and liquid. For gases, also gases 1 atmosphere at the temperature of. So see this thing which otherwise will be ruined. So this is how much? For gases? By definition, by convention, 1 atmosphere. Tell me what is the difference between this and this? Tell me what is the value of this? Can you tell me roughly? This one. It is 1 atmosphere. What is this? So try to understand. See, there are so many things to understand. What is pi? Pi zero you are written for. This is for gas. This is for iron. Iron, pure iron, and iron in steel. Pi means steel, pure iron. Pi zero. What is that? Saturated vapor pressure of iron, sir. So liquid iron, sir. How much it will be? How much it will be? Say 10 to the minus 2 atmosphere, 10 to the minus 3 atmosphere, very small, very small. Saturated vapor pressure. Pressure, see, that figure, liquid vapor pressure, exactly. This is vapor pressure. This is nitrogen pressure. In this room, what is the activity of nitrogen in this room? What is the activity of nitrogen? Is nothing but Pi, the pressure of nitrogen. What is that? 0.8. 0.8, 80%, partial pressure is again mole fraction time total pressure, you can do this. So this is, remember, so what is the conclusion? That is, box this, for gases, AI is Pi. Follow, and you can box this also, there are too many things, how will box them, okay? Follow this, but this is important, don't confuse Pi 0 here, I cannot write so many things, Pi 0 here, Pi 0 there. This is for condensed phase, means vapor pressure, sir. Activity is related to fugacity to vapor pressure, sir. Solid fugacity vapor pressure, accompanying vapor, or this is this. Now tell me, what do you see from your Sukolan? The activity unit, I said activity has no unit, right, somewhere? But here you see what? Think, and while I write here, think. Revise your answer. AI has no units. AI has no units. Since it is a ratio. What this? If I always write the fundamental one, always in my practice. Then write Pi. The next moment I write Pi by Pi. Okay? This is vapor pressure. For gases, it is actual pressure. Vapor pressure is awfully different. Water will exert actually under 100 degrees. What is the vapor pressure today? Water vapor pressure is 0.3 at 69 degrees centigrade. It may be 0.003. 0.03 say. And what is the standard state of gas? 1 and point. What is it? Yes. Then what is? How will you reconcile this? So Kolan will reconcile us. This. So this has no unit since it is a ratio. Has no units, but it is a looks like a ratio. Pi 0 hidden, sir. Another denominator unit has hidden because of 1. That is the whole trouble. Careful. So this part is over. Okay. So now move on. I think Gi bar minus. So I write finally that the two relations that you will never forget. First is I said dg prime dp. I write this on the top for you. Tell me Gi bar dni plus gj bar dnj that I wrote. Never ever whole life. Oh, before this even another one. Still since I've written this, this leads to from where G prime is a function of temperature, pressure, Ni, Nj, Nk. Oh, sorry. Leads to. Right. Starting is D prime is a function, extensive property, temperature, pressure, Ni, Nj in a system, solution system. This leads to this. Or on equation, box this. Box this important. More important, in fact, I should have written on the top above it, but I write here. Gi bar, tell me, is minus Gi 0. Number 1 relation in thermodynamics maybe. Number 1 or number 2. Okay. RT ln AI. Again box. Never. RTlnF. Good, very good, very good. RTlnF. DG is left hand side. See, one thing I tell you. If you say D, you know D, you are wrong. You don't have to ask me why. This side is differential. There is no differential term on the left hand side. It can never be. This is integrated form, and this is differential form. How can you ever write? So remember. So what you said DLN, that is left hand side is also DG. Remember DG and then integrate is okay. So this is. So I remember this actual. Anyway, don't worry. RTlnK is okay. So another is very important. I told you. This also at the same time. Don't forget. At a given temperature pressure is what? Tell me in terms of. Never easy though, very easy though, but this actually I have told you. Now move on with these three. So next is what I shall tell you. Start now. Now I have start. Now next topic maybe is better. Next topic or next consideration. See, I have actually spent a lot of time on partial mode of energy, which is the number 1. I have written though here beneath it 1. For the 1, or if it is 2, then I will let you know which actually supersedes it later on. But today, quickly remove this. Now press start. Chemical reaction. Now is the beginning. Next consideration. Consider the chemical reaction. Start. So we are going to consider. Let me write. Let us develop. Consider the chemical reaction. This chemical reaction A plus gas phase. Consider the gas phase chemical homogeneous gas phase chemical reaction. Start. What is the reaction? A, writing here, gas plus 2B gas goes to 3C gas. The second law tells us whether a reaction will occur or not. Today is the time. We will use the second law and say whether this reaction will occur or not. Means all possible reactions on Earth will answer today in 10 minutes or 15 minutes. Why? What is the criterion? Whether a reaction will occur or not. So I start with this. A B plus 2B is 3C. Constant reaction, homogeneous reaction A plus B to 2. Okay. What is this? I am going to write this. What is this? Okay. What I write here? Okay. So let me give you this. What is the DG prime TP? What is this? 2 A plus 2B. Write this. DG prime TP. Apply this. GA bar DNA plus GB bar. Let me sketch this problem. Plus GC bar DNC. Follow this. I'm sketching this problem. Follow this nicely. Follow. I have taken in a container. What I have taken? Na moles of A. Okay. Nb moles of B. Nc moles of C. Gas. Okay. What is the temperature? Again, as you know, as often I consider, at this temperature and pressure. Question whether chemical reaction. Whether the chemical reaction A plus 2B goes to 3C will occur or not. This is the question. Answer this question. I have taken randomly. Right here. What is the temperature means thermostat? Pressure means pressure fixed. Okay. I am very sorry. First line I actually not very serious mistake I made, but Second line, that will be second line. G prime. I'm writing something. Follow me. G prime. Previously I wrote though, but now you follow more seriously. G prime of this system is function of temperature. This I were used to write pressure first, maybe no problem. Pressure, temperature, and what is this? Tell me. Na NC. Now you try to understand this. See, follow this. This you have written. No, because everyone writes this. No, you check whether we are entitled to write or you have really used this or really actually utilize this line, or this line is compatible with this figure, this experimental arrangement. You have taken in your lab this condition. You don't have cylinder piston, maybe horizontal reactor. Taking Na, Nb, Nc, and okay, at the temperature, pressure. Open thermosphere is the constant pressure, and here thermostat is actually controlled by temperature controller. And you are wondering, you wonder actually whether this reaction takes place under this condition. This is the given condition. Na, Nb. See, can you write this? Remember, this you always remember. I said these are independent variables. This side is dependent. So all are independent. Check, yeah, it is independent. Or so you ask yourself, have I taken them independently, or is there any interdependence? Now you see, yes, any temperature I can take 1000, 1200, pressure 1 atmosphere, 2 atmosphere vacuum, and NS I have not written it yet. It means 3, 4, 5, NB 7, 8, 9, anything. C also, product also you can take. That is the idea. You can take product also. Don't think you have to take 1 and 2. No, don't think. You take any arbitrarily. So you see, these are all independent variables. In a sense, this is the degree of freedom actually. But I will not take up this. These are correct statements. And G prime is a function of this pressure temperature. You know this. Pressure temperature, why not volume temperature? You know that answer, you know. Because this is the natural choice for Gibbs free energy. And also this is actually our experimental condition. So, but natural choice. Quickly. Dg prime is, this part you know. Dg prime is, tell me. I'll write quickly. Del P at constant temperature. Like last time. No problem. Na, Nb, Nc. You have to write. No way. Plus del G prime quickly. Del T under constant pressure. Na, Nb, Nc. Write once. Then this chemical reaction now. It is chemical reaction, no solution. But gas phase is a gas phase. Gas phase. So gas phase is always a solution. Air is a solution. So plus dg prime, tell me by dna, temperature, pressure, tell me nb, nc, remaining ones. dna, please write dg prime dnb, temperature, pressure, NaNC. You have to write dnb, and last one is del G prime dnc, temperature, pressure, Na, Nb, dnc. So what is this? You know, or you write, I'm giving you, what is the name of this? Recall. First of all, or dg prime tp. Let me write this. Dg prime tp, I'm this. Means these two terms drops. So I should not cancel there, but now I cancel. And what is the name of this? Good, very good. Ga bar, and like is GB bar, write that GB bar. And this is GC bar. So write this. Next line maybe, or nicely, dg prime tp is Ga bar dna plus GB. Oh, I have written on the top also. On the top it is written there, but I am, for chemical reaction I am applying dnb. Okay. Now tell me here, from stoichiometry, this part you did in thermochemistry. With me. From stoichiometry, now use the stoichiometry now, but not here. Any value, any take. You have taken the product, you have seen. Product you may take. Any, not 1 and 2, 1 mole, 2 mole, forget that. Anything you can take, but at the same time, it is up to you whether you take stoichiometric or not. So, from stoichiometry, you follow this is the argument I gave you in thermochemistry. Remember, what is this? Please tell me. Minus dna, please tell me, minus dna is half minus dnb is 1/3 plus DNC. Why I have written this? Is I am giving, his name is 1/3 DNC. DNA is DNC. DNC. And is DNC. And it is positive. Write this. Follow. Follow. Minus DNA, why? As the reaction goes on, what happens to DNA? It decreases. So make it positive. Minus DNA. And DNB likewise minus, but DNC is plus because it gains. But this is first twice to half. Why it is half? But it is for 2. It is 2. So but what does it mean? The rate of renewal of B is twice as much. This is twice as much this. And this is produced thrice as much. So this is okay. And this I give you name, general name DN. Apply this, apply to this. So GA bar, DN is then what? Minus DNN. Minus DN from this. And then GB bar is, the GB bar is what? DNB is what? Minus 2 DN. Minus, GB bar is minus 2 DN. And it is plus 3 GC bar DN. All in terms of DN. All in terms of DN. Looks good. GC bar, DNC is what? DNC is obviously 3 DN. Correct. So you take DN in common and 3 GC bar. I am tidying up. Minus GA bar plus 2 GB bar DN. Happy? DG prime DP DN. Happy though? This is okay. Now this is known as, I tell, achha, by the way, 3 GC bar minus GA bar plus 2 GB bar. This is the free energies of this. Where it is? Where do you apply this free energy? Which state it refers to? GC bar, which state? This state understudy, right? This is the state understudy. At this state, where the reaction will occur. Means what is the state? I have taken this randomly or arbitrarily, this much. This temperature, this pressure. Whether reaction will occur or not. So this is the state under study. Again, you apply this. Follow. GA bar. See, GA bar DNA. GA bar is unchanged. Why? I said DNA will never change GA bar. Finite moles will change always. Okay. So that's why it's okay. So follow. GA bar refers back to this, and this we want. Our question is on this, not anything which has shifted to this or any progress has been made. No. At this state, whether at all reaction will occur. So it's fine and still fine, and he's also fine. So this is known as, now since you are delta G DN. What is delta G? Where delta G is nicely right. Where delta G is right. 3 GC bar minus GA bar plus 2 GB bar. This is known as what? Finance, right, in G of products. G bar products minus G bar in short. G bar reactants. I hope you will not mind this. Delta G is product minus reactant. Again I will ask again and again. Delta G, which state it refers to? Here sir, delta G. What GC bar? At that. DNA we have differential I have taken. That's why GA bar has not affected. No finite change. Okay, it's differential. Okay. Now I actually remove this. Remove this. Remove all these things. No more needed. I've already. Oh, sorry. What is this? Oh, October 12. Cautious. Okay, sorry. Actually, this is such a beautiful ink. Write this. So, delta G. You work from here. Call it equation 1. Okay, write it. Or start from here. Or dg prime Tp by dn. Dg prime Tp by dn. Oh, sorry, why? Dg prime. Oh, right, nicely. Or nicely. Even dg prime Tp is such an important issue. Right, nicely. Is what? Delta G. This you note. Note this. Note in passing. But what I will tell you, What I'll tell you, tell me. Uh-huh. I tell you this one thing I guess. I get one conclusion I make. Later on I will use it profusely. What is this? This is what? Now tell me the second law. What is the second law? Or which one I will consider? DGTP is what? Whether a reaction will occur or not, suddenly we cannot get here. We have strong theory, basis. Second law. Second law we know in details. What is the condition of spontaneity? Remember, less than equals to 0 minus dw prime, no non-mechanical, this is less than 0. Again, write what does it mean? Spontaneity or irreversibility. Irreversibility, sorry, this is spontaneity corresponding is equilibrium, means no reaction, and this is reversibility. Reversible process also under equilibrium, so never forget. So DGTP. Now you tell me it is less than 0. Now noting dn is not 0, is non-zero stuff. dn is a dg prime tp right here dg prime tp right here again. So delta call back delta g dn equation 1. Now see second law, spontaneous. I want spontaneity. Say so spontaneity or impossibility also. Corrosion reaction I want impossibility. I don't want the reaction. I want the reaction extractive metallurgy, process metallurgy. So both can be possible. Suppose I want the reaction to occur. So then spontaneity, what is the condition? Less than 0. Suppose I want to check the equilibrium. So dg prime tp is 0. But incidentally dn is non-zero. And also, and tell me positive quantity I told you, showed you, written here, I wrote here. dn is a positive quantity. Is positive. What does it mean? Delta g, if it is less than, so that means this is less than 0. This leads to, from this equation, this is non-zero, and this is 0 means which is 0? This is 0, this is non-zero, delta g is 0. That is the alternative criterion. Or when it is less than 0, this is positive, this is also less than 0. This is alternative. This leads to, so this is actually again delta g. Again, right? Oh. So this is the revised criterion, delta g. Delta g again tell me, what is the delta g? It is integration of dg. Delta g is what? Delta g, this is the answer. But I will modify a little, I will amplify this, work on this, but this is the basis. Delta g is less than equal to 0. This is actually, millions of people are saying delta g less than 0. Spontaneous, delta g is 0 equilibrium, they say. So, but what is delta g here? Tell me, what is the C?
Summation of zero products.
But refer to the question. Your problem is there at hand. This is the problem. This is your problem. So, in the light of this problem, what is delta g? So, this is 3 GC bar. This state. Question is here. Whether at this state reaction will occur or not. This is the state understand. At the given state. Will occur or not at the given state. At the given state. I'll answer. Okay, I'll develop this. Delta G I'll develop. Not 5, 6 line I'll develop. But delta, this is the basis. Delta G refers to what? Your question was, sir, I have taken sir, so many moles of A, B, C. Whether reaction will occur? So delta G, the criterion must actually refer to this state. What? How it is? How it refers? Tell me. Sir, 3 GC bar minus GA bar, and they have GA bar. See, there is NA. Means composition, and there is standard state value there. Absolute value we don't know, but GA bar is GA0 plus RTln AI and mode. So I know sir GA bar. Yes, GA bar, GB bar, GC bar. So use them, find out whether it is negative or positive or 0. If it is negative, then it is spontaneous. How will get sir? 3 GC bar minus. This is the perfect criterion. Get sir. How will you get sir? Is okay sir. Academically okay, fine sir. Principle okay. How will you get sir GC bar? Who will give? You wrote for example 100 joule, 130 joule, but now it's a practical thing. This is a practical reaction. So CO plus HAPO2 is CO2. Say CO2 plus carbon is 2CO. Say iron oxide plus carbon monoxide is iron plus CO2. So titanium dioxide. So who will give us a GA bar? That is the difficult part. But we will see solving a roundabout manner and nice manner rather. So this, but you have understood the delta G refer. Another point, mental block. Delta G sir, state 1 to state 2. Delta is first application of the first law for ideal gas expansion. or etc. etc. Sir, 1 to 2, delta U 1 to 2, Q 1 to 2, delta H 1 to 2. So this we started. But this is, sir, which to which, sir? You have only one state you have written. This is very surprising. Mental block. This delta G is not referring to two states. At this state. So at this state you have a delta. Left. So at this state, sir, delta how referring to one state, sir? Surprising. We have never heard this. So far 1 to 2. Two figures often, sir. State one state. One state delta G. What does it mean? Sir, take a look. This all refers to one state. How then delta? Product and reactant free energy difference, as this is as given here. So this is the meaning of that. But then I will later on show you. Today time is short. Is actually that yes, previous concept of 1 to 2 I will show you, but difficulty etc etc. But try to what we are trying to solve at a state of the reaction local. You answer delta G less than 0. But next is a practical problem. So how shall I? So who will give us? How he will give us? They will give us this value of GC bar, GA bar, GB bar. No one, because absolute value in thermodynamics is not knowable. Changes, only changes matter, sir. So how, sir? This solve quickly, 5 minutes, okay? So I am removing this. This is no longer necessary. You know the reaction you already seen, or I am right. See how interestingly this is solved, this problem. Delta G, start quickly. Now see how they are, I am writing next. Delta G is 3 GC bar minus, tell me quickly, GA bar plus 2 GB bar. Write the reaction, reaction A plus 2B goes to 3C. Reaction under study. Otherwise, you can abstract your actual, see, now what is 3 GC bar quickly? Tell me, GI bar. GI bar. So you have to do something, you cannot be stranded there. You have to find how to get delta. You got the criteria, but you don't know how to resolve this. GI0 is plus RTln activity. Bring activity. Activity means composition. Yes, a composition we know, sir. Mole fraction we know. Na by total, Nb by total. So hence activity possibly. For gas also activity is partial pressure. Partial pressure is what? Mole fraction time total pressure. Pressure is knowable, so measurable. So activity is coming, but still difficulty. But I am writing at least GC0 plus RTln activity of, okay, minus, right, GA0 RTln activity, not take much time, plus 2 times GB0. See, I have used this today, we started this, now I am using this freely. Now can I actually just a little bit, 3 GC0 minus GA0 plus 2 GB0, give a third bracket perhaps, and then write, 3 RTln, I am writing this way, you don't mind, I hope. RTln activity C cubed activity A times activity B square. Please take a look. You check this, correct? Nice, correct? Correct? Ln is a 3 ln means RT is outside ln AC whole cube, log. Okay. Now tell me, this activity refers to what? The activity means I always ask, sir. Anytime you write activity, free energy will ask, who's free energy? And when free energy is such things, whose activity of C, where? That is equals to mole fraction, partial pressures, etc. for gas. This is a gas phase reaction. So partial pressure, direct answer, Pi by Pi 01. A moment ago, I asked him the unit for gas Pi. So fine, no problem. Pi is of course dependent on mole fraction time total pressure. Yes, that is true, mole fraction, but where it is? Physically where it is? Activity of C? Always this. Remember again, activity of the state and the study relative to What is the standard state for a one atmosphere gas? Always standard. Standard is always based on the standard one atmosphere standard. So this is known as what? Delta G. If it is delta G is this, what is this? Delta G 0, like your delta H 0, standard enthalpy of formation or enthalpy of heat of reaction, standard enthalpy of reaction. This is standard free energy of reaction. Plus, good boy. So right here, shall I write for your benefit and for what is state understanding? This refers to the activity at the state. Yeah, back here, state understanding, or we call it state understanding. Quickly. I'm close. RTln cubed. So by the this call this Q. Q means quotient. This we call Q is for quotient. Activity quotient. Activity quotient. Actually, this is sometimes we write state answer actual. We say actual means what actually happens. State answer. Delta G. Happy? Books, very important, very important. I'll get back to it. Now quickly, sir. Sir, you have solved this problem. Well, how you have solved? We don't see, sir. Activity is measurable. This side is measurable. Because activity is not partial pressure. Very easy. Mole pressure, I have taken myself, sir. We have taken ourselves. We know very well. We know pressure very well. So this part is very good. But again, sir, delta G0, sir, who will give us? And this. But this again standard state, so what? What's the value? Absolute values we don't know ever. 1 atmosphere nitrogen at pure nitrogen, 1 atmosphere. What is the free energy, sir? I don't know how many people know. We don't know. So absolute free energy, absolute internal energy, absolute only for ideal gas internal energy is 3/2. Remember? And PV enthalpy, but this free energy entropy is there. Okay, so for solids it may come into picture. So we don't know. So but there is a solution. This follow. But now at equilibrium, tell me at equilibrium, say I am applying, hitting the equilibrium condition. At equilibrium, this I am applying to equilibrium state. This is not non-equilibrium. But at equilibrium, what? If it were at equilibrium, what would be the delta G? It is somewhere. Shall I write here for you again? Again, this means spontaneity, irreversibility, and equals to equilibrium. Delta G is 0. I told you. The whole world actually is saying this, delta G is 0, equilibrium, delta G is less than 0 means negative for spontaneity. They perhaps don't know beyond this, as far as thermodynamics. Negative, delta G negative. What is the criterion? Bhai Babu, see? That's why I should not talk like this, okay? And now delta G is 0, the substitute. So 0 is, I'm constantly applying these to equilibrium state, extended, if it is equilibrium. 0 is delta G0. Will it change? Standard state? Standard state, nothing to do, so it's sitting idle there. 1 atmosphere free energy. So how it doesn't have to do with equilibrium, non-equilibrium. Plus RTln Q at the equilibrium state. Let me explain. Q is what? Again, Q is what? Back. Activities here. It is not equilibrium or equilibrium, non-equilibrium. We don't know. We want to judge it. So, but at equilibrium, after reaction, suppose reaction, there will be equilibrium state. So Q, when they will attain equilibrium. Then Q at that time, Q at equilibrium state. This is actually non-equilibrium state. So Q, because it corresponding to delta G is 0, Q equilibrium. This is known as famous, very famous, world famous equilibrium constant. Thermodynamic equilibrium constant. Q equilibrium is okay. The state understand. Okay, so I'm writing this. So this is known as, right, delta G0 plus RTln K, right? K is Q equilibrium is again quotient, but what? At under equilibrium is thermodynamic equilibrium constant. I should write it. Equilibrium constant, right? Nicely. This is such an important, respectable term, or simply equilibrium constant. Q equilibrium. That means if this activity value is at equilibrium. When it will be equilibrium, that value this is. Or delta G0 is what?
Minus RT.
Okay. Now you may ask, sir, how, sir, even so? So you have done very good job, but what does it mean, sir? Equilibrium constant. How shall I get this value? I'm writing, complete this, putting back into quality equation 2 maybe, I do not know it is 2 1, putting back into 2, from 2, from equation 2, put back quickly, delta G is delta G0, oh sorry, minus RTlnK plus RTlnQ, write this nicely, putting back RTlnK plus RTlnQ, what is this? RTlnQ by K. Tell me. So delta G. So now you understand, okay? You might say, sir, very good, sir, you're done. But how will you get K? How will you get K, sir? So this you apply. So Q is okay. Q already okay. Okay. Straight on the study. This again question back. Original question. Sir, delta G, negative, positive. Q, understand, sir? Activity ratio, etc. K is what, so suddenly injected some term and K is equilibrium. Activity, what is this? Activity of C, activity of A, activity of B square at equilibrium. Equilibrium is recognizable. A reaction occurs, changes, and when there is no more change, then that is the equilibrium. Get out the activities. How will you get out? Mole fraction, partial pressure. Get the analysis. Gas analysis is possible. Composition and partial pressure, get the activities at equilibrium. So you will get the, in fact, this is how delta T is measured experimentally. This one I measure, and there is another method also later on, but from equilibrium constant. Find the equilibrium, get the equilibrium value. So delta G is RTln by Q by K. So like this, time is over. Exceeded. Is actually that's here. I'm actually at the end of this. Now tell me, Sukolan. See, interesting. See, the condition is what? Spontaneous. Never drift from this. Where is? Never drift from this. This will gradually lead you to this. Tell me, this leads you next important, this step. This step to this step. Okay? And okay, so tell me, now, so from, I have given a name to this, delta G less than equal. So, since, right, delta G less than 0, following. So, I remove this part I am doing, unnecessary. Star this, double star. Since, following delta G less than equals to 0, following the second law, all second law, I'll give you a list of the second law, then I'll stop. For the second law, that is delta G less than equals to 0 in this format, simplified, modified, advanced, okay, and suitable for our work, delta G less than 0, what you get when it is? When Q less than K and Q is K, greater than is not given, it is just I am giving. Greater than, what is this? What is it? It is sir, less, when Q less than K, delta G is negative. Negative means top one, spontaneity. Spontaneous or irreversible? Spontaneity, irreversibility, add this. And this is equilibrium, reversibility. This is what you write? That's right. Three things. Impossibility. Very good. Okay. This part. So I am jotting down the different things here. So for your, this is the last one. But part of this is the last. There is no more development. Here you have to stop. Okay. The Q less than K. Q. So and then, so please box this, by all means. Box this. This is what I said. The number 1 and number 2. This is maybe the number 1 equation in thermodynamics. Every day 100 times. Every day 100 times you are going to use. You will see soon I will take up problems. Every day 100 times. And another one I said, which one? Because let us see. Gi bar minus Gi0 is RTln. You may note this. That leads to this. I know 3G bar. That which I removed. You use not 3G. Gi bar is Gi0. Then delta G0 is similar actually. See, Gi bar. I have removed this. That's I show. Gi0 plus RTln. Gi0 gives rise to delta G0. I am telling you. And RTln activity gives rise to this Q. Okay. And then actually applying this. Okay. So quickly. So you write. Say this 1 or 2 minutes. Is okay though? 1 or 2 minutes. So the second law statements. You will just summarize. It will help you. Summary. So summarized means the which is actually many Kelvin will not write that, but start in terms of Gibbs energy, right? In terms of G, Gibbs energy, in terms of G. But first of all, dg prime or dg simply tell me. Actually, first of all, since this we should write always, we cannot forget actually the original one. What is the original? Always original is what? ds universe. Nothing like that. Everything is coming from that. You check, original is ds universe. Achha, I'm giving only spontaneity and right? Yes, spontaneity. Everything this. Achha, I'll write later. From this, what we got? Tell me. DGTP. This was done before your semester. Within the semester, no? There are 3, 5, 4, another. DGTP, DATV, DHSP, DUSB. Good boy, good boy. DGTP is less than equals to 0. Achha, achha, is okay though. Shall I write here? Since summarizing, I don't care about this anymore. Don't care. So you write nicely again once more. Spontaneity what is irreversibility and equals to equilibrium reversibility. Quick, done. DGTP is 0. Next is what? Follow this. DGTP, you have this. Achha, DGTP, DG prime, G. You can understand G prime and DGT prime, DG prime TP divided by DN also, please write. Right, please. This is what is the name of this? DG prime TP is I wrote somewhere. That is delta G. Yeah. No, that is right. That is. Achha, right. Since it is so important. So right, leads to. Give arrow. Leads to. Achha. Another thing before let me complete. What else? You are very close. Less than 0 means last is this. Nothing else. Q less than K. I remove this. What is this? Tell me. Q means actual activity ratios under quotient under study. That is my problem. You know, I often use the phrase you know best. You know the best. Anyone else does not know. What is Q? Because that is your problem. Who else will know? So how many moles you have taken? How shall I know? What pressure? So Q is activity ratios. K is a standard. Standard stuff energy. It is tabulated. Get in the book. Apply this equation. R is 8.314. Temperature. Get out. K. Q less than, and that ends. Yeah. So that ends. Okay. Only thing I tell you, what it signifies, not today, I stop now. What it means now, if we plot G prime TP versus N, if I ever, just next diagram, not just to show this, next I do this. G prime TP, nothing but N, then a curve will generated, this minima. What is minima means dy dx is 0. So dy dx is 0. That means G prime TP, tell me, is in this plot is attains a minima. Attains the minima. Minimum means this point. This point is what? When it is 0, not less than 0, is 0. If it is 0, for right, for this condition, dg prime dy dx is 0. dn is 0. Less than 0, I'm not talking. This actually, less than 0 I'll consider also here. This is less than 0, this point. Next day, not today. So what is this? He attains a minima. So what does it mean? This is also okay, talked about millions. 3 things they say. Free energy negative, spontaneity, and then what else I said? Free energy delta G is negative, and what I said? Free energy and delta G is 0 at equilibrium. And this is another. You see in your books already you have perhaps started. Free energy is minimum, attains a minimum at equilibrium. Attains a minimum. Who says this? AJ. This says that a dy dx minimum is dy dx is 0 under what conditions? Under what conditions? 2 at least you know. When y is independent of x. This one, another is actually maxima or minima. This actually, since this decreases spontaneity and stops at equilibrium. Okay. So question, have you got the answer? I started. I'm just. Answer question what? whether the reaction A plus 2B is 3C under the given conditions that I chose myself, Na, Nb, etc., will the reaction will occur? Have you got the answer? What will you do? Delta G less than 0. Delta G is either use delta G through the relation. What is the relation? Delta G is delta G0 plus RTlnK. Is there with you? So delta write this one. Delta G is delta G, whichever you like, whichever suits you. RTln, I'll show you next. RTln Q. Either this or Q less than K. If happens to be negative, then you say, sir, reaction under this condition will occur. Whether reaction will occur is $1 million question. Occur. If you find it to be 0, what will you say? No, sir, it has already, this composition is actually equilibrium composition. No hope, sir. And if we say positive, sir, it is still actually against. There is no hope. There is also no hope. Equally, both are no reaction, no occurrence. Okay, but since actually I have taken this, see, difference between delta G, the next I will tell you maybe, not today. Delta G is 0, no reaction. Delta G positive, no reaction. Can you tell me the difference? On difference you can see, delta G is 0 means either this direction, forward, A plus 2B is 3C, I wrote somewhere, I have removed part of it. I forward, no hope, backward, no hope. But if it is positive, forward positive means backward is what? Negative, because it is mathematically, always mathematically. 3GC bar minus GA bar plus 2G bar. When backward, reactant will be product will be reactant, minus, it will be minus. So then it is positive, spontaneous. This is additional statement. But another question was, yes, sir, I can now in a position to judge whether the reaction will occur or not. Thank you very much. Okay, with these words, we have actually completed today's lessons, and let us call it a day.